Okay, so here we've got lesson 6.3 and more information, more special things about a parallelogram. I'm going to start out if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. And on a parallelogram, the diagonals actually bisect each other. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. Okay? If you've got a quadrilateral and you don't know anything about it, except for the fact that the opposite sides are congruent and that they are parallel, then we have a parallelogram. Let's look at finding some values. So if the diagonals of quadrilateral A, B, C, D bisect each other, and they bisect at point G, then ABCD is a parallelogram by theorem 6-7. Okay. And if we know that the diagonals of a parallelogram bisect each other, then we know that this value is the same as this value, because that's what bisecting means. And we know that this value is equal to this value. So 2y minus 80 is equal to y plus 9. All right. I will solve this side first. So if I collect all the variables to one side, I want to put the x's together, so that makes that 2x. So I've subtracted 8x from both sides. And now I'm going to add 24 to both sides. So 2x is equal to 36. X is equal to 18. Okay. If I come back to this side, if I put the variables on one side, I'll subtract y from both sides. So y minus 80 equals 9. Y is equal to 89 because I add 80 to both sides. All right. If x is equal to 18, or when x is equal to 18 and y is equal to 89, then this is a parallelogram. So we've assumed that they bisected. We solved for the values that it would take to have the two sides of the line be equivalent, and it is when x and y are at these values that it solves the equation, a definition for a parallelogram. All right, how about this one? Is this quadrilateral a parallelogram, can we say? And they're telling us that AB is congruent to CD, so they're the same length. Is this enough information to help us conclude that this is a parallelogram? Well, if the only thing that we know is that one pair of the opposite sides is congruent, that is not enough to conclude that that is a parallelogram. How about this one? Suppose that I'm told that the measure of F is 105 and both E and G are 75. Is this enough information to conclude that we have a parallelogram? Well, here's our formula about the sum of the measures of the angles. So I've got 1, 2, 3, 4 sides in the quadrilateral. So these 4 angles will add up to be 360. Or my unknown value plus 75 plus 105 plus 75, it adds up to 360. So X is equal to 105. And our theorem says if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Because both pairs of opposite angles are congruent, the quadrilateral is a parallelogram. By definition. Or by theorem 6.6. All right, here's a couple more practice problems. So we are going to presume that these are parallelograms, and for what value do the variables need to be to convince us that this is a parallelogram. All right. As a reminder, if for a parallelogram, the opposite angles will be congruent, and the opposite sides will be congruent. Okay. So if I want to solve this one for A and C, this length is equal to this length. 3C minus 3 is equal to C plus 1. If I subtract C from both sides, I have 2C minus 3 equals 1. If I add 3 to both sides, 2C equals 4. If I divide both sides by 2, I'm left with C is equal to 2. All right. And by a transverse cutting parallel lines, I know that this angle plus this angle equal 180. They're supplementary. So A plus 40 equals 180. 2A plus 40 equals 180. Subtract 40 from both sides. 2A equals 140. A equals 70. So when C is equal to 2 and when A is equal to 75, this is a parallelogram.